This is our heat powered stove fan. It just sits on top of the wood burner and the heat makes the fan go round. The problem with this, we've had it a few years, and over the years it's getting a lot harder and harder to start. You need higher and higher temperatures. And if you look at the motor, it's quite a lot of play in the motor and it's quite noisy when you spin it. So what I'm going to do is replace this motor with a new one. These are, I'm not sure how much these cost, probably about 50-60 pounds maybe, not sure what they are now. But the motor was only £5, replacement motor, just £5 on eBay. So I'm going to put that in there. These work by using this little white device in here called the Peltier device, and it produces a Peltier effect. Basically the bottom half sits on the fan, it gets hot, and all these fins at the top, it's a lot cooler, so you have a temperature difference across this. I first came across these Peltier devices probably in the early 80s. One of the scientists where I work gave me one, and I think he had a free sample and asked me to look at it and see what I would make of it. So I remember putting it on a meter, a voltmeter, and it sort of generated a few millivolts when I was holding the thing. So then I put it on ohms and discovered that the resistance kept changing. In those days there wasn't any internet, so I had to go into our technical library and look it up on an encyclopedia to find out exactly how they worked. Basically it's either a thermoelectric cooler or it can operate as a thermoelectric generator. It's like a semiconductor. It uses, I think it's bismuth telluride or something like that as a semiconductor. And basically it works in two ways. If you put heat across it, it'll generate a small voltage across a PN junction, and it works in reverse. If you actually apply a voltage on it, then the heat is absorbed at the cold junction of the semiconductor and radiated at the hot junction. So actually I've seen these also in those little fridges you get, just a little drinks cooler, just a small little fridge, not very powerful but enough to keep your canned drinks cool. So I'll go and try and change this. First thing is to get the fan off. Little grub screw and Allen key type. Should hopefully pull off. That's that off. Two screws holding the motor casing in, and the panel at the back might be worth taking off to get to the connection. And there's the connections. It's awkward to get your fingers in. I think I'll take the other end off. Try and pull this one apart. It's not easy. Get your fingers in. You get fingers in at both ends. Well, that's a little house. That's the motor in its housing. Very small screws here, so let's get those out. So that's the original motor. Noisy when you spin it. There's a lot of play in there. Whereas the new one, almost identical. As I say, it was about £5 or £6 on eBay. Much better than buying a whole new fan. A little bit of play, not as much as that. Quiet when you spin it. Try and reassemble it. A couple of screws to line up. That's it back in. Now that went on the back like that. Right, small problem now. The new motor, just discovered it. The new one here, the connection is a firmware connection, and on that is the old motor, and on the new motor, the So I'm going to have to swap the wires over, just unsolder them and solder them onto the other new motor. I'm just about to unsolder these wires for this connection and put it onto the new motor. Now it's actually marked positive, so there is a positive there, and it's also a small marking on here. It's hard to see, but it says positive as well. So put it the right way, otherwise this fan will spin backwards. All I need to do now is put the fan back on. Feels much better. We're going to try it. Just going to try it now. See how long it takes. There it goes. Fixed.